All right, problem number 6. Using special right triangle rules, find both missing side lengths. Let's talk about those special right triangle rules first, and then we'll go through and do this. These are things that you have to know for the test. There are 3 special right triangle rules that you guys need to know. We have 45, 45, 90 triangles. And there is one rule that you need to know for the 45, 45, 90s. The hypotenuse is equal to the leg length times the square root of 2. Remember, in a 45, 45, 90, the 2 legs are the same size. It's an isosceles right triangle. If it says isosceles right triangle, that's the same thing as a 45, 45, 90. And then we have our 30, 60, 90 special right triangle. There are 2 rules that we need to learn for this one. One for the hypotenuse and one for the long leg. Hypotenuse is equal to the short leg times 2. And then the long leg is equal to the short leg times the square root of 3. You need to know all 3 of those rules and how to use them. So let's go ahead and use those special right triangle rules to solve these 4 problems. In the first one, upper left box, this piece that we have right here, 12 square root of 3, what part of the triangle is that? That is the hypotenuse, absolutely correct. Across from the right angle. What kind of special right triangle is this one? It's a 30, 60, 90. Absolutely correct. So 30, 60, 90 triangle. We know the hypotenuse. We do not know the short leg. Hypotenuse is equal to the short leg times 2. We know that the hypotenuse is 12 square root of 3. And they're calling the short leg n in this picture. So to find that short leg, we're going to divide both sides by 2. That'll cancel it out on the right. On the left, I look at these 2 whole numbers. Does 2 go into 12? Yes. So we divide those. I get 6 square root of 3 for n. And then we still need to find the long leg. The long leg is equal to the short leg times the square root of 3. They're calling the long leg on this one m. We just found the short leg. How big's the short leg? 6 square root of 3 times the square root of 3. Remember, when we smash the 6 and the square root of 3 together, there is a multiplication symbol there. So I have the square root of 3 being multiplied to itself. That means I have the square root of 3 squared. And that's important because what happens when I have the square root of 3 squared? Cancels out the squared and the square root. So I end up with 6 times 3. And 6 times 3 is 18. Very nice work. What kind of triangle do we have in the upper right? Another 30, 60, 90 triangle. If you see a 90-degree angle and a 60, or a 90-degree angle and a 30, it has to be a 30, 60, 90 triangle. So the hypotenuse is equal to the short leg times 2. And the long leg is equal to the short leg times the square root of 3. This 2 that we have right here, is that the hypotenuse, the short leg, or the long leg? That is the short leg. X is my hypotenuse. And so that means y down here on the bottom would have to be my long leg. So to find that hypotenuse x, we take our short leg of 2 and we times it by another 2. So my hypotenuse is 4. The long leg, which they are calling y, is equal to the short leg, which is 2, times the square root of 3. So 2 radical 3. Mia. The bottom 2 are both what types of triangles? 45, 45, 90 triangles. A 45, 45, 90 triangle is also an isosceles right triangle. I have 2 angles that are the same, so what would that mean about my sides? 2 sides are the same. It's never going to be the hypotenuse that's one of the congruent parts. It's the other 2 pieces. So that means that n on this triangle has to be 8. It is congruent to the other side there. The hypotenuse, though, is equal to the leg times the square root of 2. The hypotenuse they're calling m. The leg is 8, so 8 times the square root of 2. So m is 8 radical 2. On this last one, lower right, the 4 that they are giving me is the hypotenuse. U and V are the same size. So if I can figure out one of them, then I automatically know how big the other one is. Hypotenuse is equal to leg times the square root of 2. That hypotenuse is 4. So I have 4 equals L times square root of 2. I need the L all by itself, so we're going to divide both sides by the square root of 2. That'll cancel it out on the right. On the left, am I allowed to have that radical on the bottom? Nope, we have to rationalize it then. So we multiply top and bottom by square root of 2. So we multiply top to top and bottom to bottom. So I would have 4 square root of 2. Square root of 2 times itself would be square root of 2 squared. Squared and square root cancel each other out. So I have 4 square root of 2 over 2 equals L. And then I need to divide these two numbers. What is 4 divided by 2? So 2 square root of 2 is equal to my leg L. That means U is 2 square root of 2. And V is also equal to 2 square root of 2. They are the same size. What else would you guys like to see from the review? Yes. Number 8. Absolutely. Find sine A, cosine A, tan A, sine B, cosine B, tan B. Right, so let's do sine A, cosine A, tan A first. So I'm standing here at angle A, and I'm going to label my sides based on standing there. The hypotenuse is always across from the right angle. So no matter where I'm standing, that's never going to move. 8 is my opposite side. And so that means 15 is my adjacent side. Sine of angle A is opposite over hypotenuse. My opposite side is 8. My hypotenuse is 17. They wanted me to write it as a fraction and as a decimal. I cannot reduce 8 over 17 at all, so that would be my fraction in simplest form. When I pop 8 over 17 in my calculator and I round it to 3 decimal places, I get 471. If you round it to the nearest hundredth, that would just be 47. Thank you. So there's sine of angle A. Cosine of angle A is adjacent over hypotenuse. Our adjacent side is 15 over the hypotenuse of 17. And I can't reduce that fraction down at all, so I'm going to leave it as just 15 over 17 for the fraction form here. When I pop that one into my calculator, 15 divided by 17 in my calculator is 0.882. If you take it out to just 2 decimal places, it would be 0.88. And then tangent of angle A is opposite over adjacent. Our opposite side is 8. Our adjacent side is 15. I can't reduce 8 over 15 at all. The only things that go into 8 are 2, 4, and 8. The only things that go into 15 are 3 and 5. So I can't reduce it at all. When I do 8 divided by 15 on my calculator, I get 0.533 when I round it out to 3 decimal places. So now to do angle B, I'm going to redraw my triangle here so that I can relabel it. Here's B up here, C, A, this is 15, 17, and 8. So now I'm standing up here at angle B. My hypotenuse stays 17. Now my opposite side is 15, and my adjacent side is 8. So to do sine of angle A, opposite over hypotenuse. Well, now my opposite side is 15. My hypotenuse is still 17. That's exactly the same as cosine of angle A. That's not a mistake. So 0.882. Cosine for angle A, sorry, that's angle B, not angle A. I'm so sorry, guys. Angle B. I circled angle B, I circled it in blue, and then I wrote the wrong thing. Many apologies. Cosine for angle B, adjacent over hypotenuse. When I'm standing at angle B, my adjacent side is now 8. The hypotenuse is 17 still. That's exactly the same as sine of angle A. So 0.471 when I put that in my calculator. And again, I'm just putting the fraction in my calculator. I'm dividing the 8 and the 17. Tangent of angle B opposite over adjacent. Well, my opposite side is the one that's 15. My adjacent side is the one that is 8. So 15 over 8. Notice it's the same 2 numbers as tangent A, but they're flipped. And when I do 15 divided by 8 in my calculator, I get 1.875. What other questions would you guys like to see? 20, all 4 parts? Okay. Let's go look at number 20. The directions on number 20 say to solve the triangle. When the directions say solve the triangle, this means to find all the missing sides and angles. How many angles do we know on example A? We know 2. We know the 90-degree angle and the 35. So let's find that third angle. How would I find the third angle then? Yep, triangle sum theorem. We're going to add together the ones that we know and minus it from 180. So when I add the 90 and the 35 together, I get 125. The measurement of angle K plus 125 degrees equals 180. And then I minus it from 180, and you get what for angle K? 55 degrees. So there's the first piece. Now we know all 3 angles. How many sides do we know? Just 1. We need to find the other 2 sides. Remember, I always stand at the angle that they told me about. I always stand at something that was given to me, never something that I found in case I made a mistake. We're going to need to find the hypotenuse. We know the opposite side, that's this 15. And we're going to need to find the adjacent side. Do you guys want to find the hypotenuse or the adjacent side first? Hypotenuse, sounds good. If I want to find the hypotenuse, and I know the opposite side, so now I'm thinking SOHCAHTOA, SOHCAHTOA. Since I want to find the hypotenuse, I need one of the ones that uses the hypotenuse. So either sine or cosine. So I know I can't use tangent to find the hypotenuse. Have to use sine because I know the opposite side and I want the hypotenuse. So sine of 35 degrees is equal to opposite over hypotenuse. My opposite side is 15. And I'm going to use h for hypotenuse. Multiply by the denominator. So multiply both sides by h. So I have h times sine of 35 degrees equals 15. And then I can divide both sides by the sine of 35 degrees. (15) divided by the sine of 35. Yes. 26.151 or 0.152, depending on how you round that. So that would be my side KJ. We still need to find the adjacent side. So once again, SOHCAHTOA. I don't care about the hypotenuse anymore. Now I'm looking to find the adjacent side. I know the opposite and I want the adjacent. Which one of these do I have to use if I know the opposite and I want the adjacent? Tangent. Since I want the adjacent, I can't use sine at all because it doesn't have the adjacent in it. And I don't want to use the hypotenuse that I just found. I want to use the information that they gave me, which is the opposite side. So tangent of our angle, which is 35 degrees, equals opposite over adjacent, so 15 over A. We're going to solve this for A, so I multiply by the denominator. We multiply both sides by A. So I have A times the tangent of 35 degrees is equal to 15. Divide both sides by the tangent of 35. And we get that that adjacent side is about 21.422. So side LJ is about 21.422. Part B. You could do part B using sine, cosine, and tangent. But there's something I notice about this one that means I can do it faster and easier. It's a 45, 45, 90 triangle. So that means I automatically know that angle X is 45 degrees. It also means that I know the length of XY. How big is segment XY? 82. In a 45, 45, 90, the hypotenuse is not the congruent side. Speaking of the hypotenuse, we still need to find that. Triangle sum theorem works for my angles. So I could have used that to find the other 45-degree angle if I needed to. We have to use our special right triangle rules, or you could use sine, cosine, tangent, or you could use Pythagorean theorem. But the hypotenuse of a 45, 45, 90 triangle is equal to the leg times the square root of 2. And this is something that you need to know. Please, please, please remember your special right triangle rules. How big was that leg? 82 times the square root of 2. So that means XW, which is the hypotenuse, is equal to 82 radical 2. Two of the 4 parts down. Part C. How many sides do we know? 2. What do we use to find the third side of a right triangle when we know 2 of them? Pythagorean theorem. So that's the first thing we need to do on this, is find that third side. A squared plus B squared equals C squared. In the place of C, we have to put the 29 because it's our hypotenuse. The 15 can go in for either A or B. It does not matter. I'm going to put it in for B because why not? I'm going to leave that side there A, so A squared. So I have A squared plus 225 equals, what is 29 squared? 841. So I'm going to subtract 841 from both sides. Sorry, no, 225. I'm so sorry, guys. Subtracting 225 from both sides. Try that again. What is 841 minus 225? 616. And then we have to square root both sides to get rid of the squared. So the squared and square root are going to cancel each other. So A is equal to the square root of 616. I have to see if that'll simplify at all. What can go into 616? Try it. Just 2 and you said what? 308. So 2 times 308. What goes into 2? Just 2, right? What can go into 308? 2 times 154. So I've got a pair of 2's. I like that. I'm going to go ahead and pull that out. So this would be the square root of 2 squared times 154. So the square root of 2 squared times the square root of 154. Squared and square root cancel. 2 times, what can go into 154? 2 times 77. What goes into 77? 7 and what? 7 and 11. What goes into 7? Itself. What goes into 11? Itself. I've got 3 prime numbers here. Nobody else is going to find a match. So I'm going to have to multiply them back together. So 2 times the square root of 154. That is the length of side PQ. So PQ is equal to 2 square root of 154. Or I could put that in its decimal form, which is 24.819. Whew, we still have to find some angles. We need to find both angles P and N. Which one do you guys want to find first? P sounds good. So I'm going to circle angle P. I'm going to label my triangle based on standing up here at P. I already have the hypotenuse labeled. 15 is the opposite side. PQ is the adjacent. I don't know anything about the adjacent side. So SOHCAHTOA, SOH, CAH, TOA. Opposite and hypotenuse means we're going to use which one? Sine, because it has opposite and hypotenuse. Tangent has opposite, but it also has adjacent, and I don't have the adjacent, so I can't use that one. So sine of my angle, P, or you can call it theta if you want to, is equal to my opposite side, 15, over my hypotenuse, 29. How do I get the sine and the P split apart? Inverse. So P is equal to the inverse sine of 15 over 29. So the measurement of angle P is right about 31.147 degrees. To find angle N, you can do one of 2 things. To find angle N, I can stand over at angle N and I can relabel my triangle. And I can figure out whether I would use sine, cosine, or tangent. But what do you know about the angles of a triangle? They add up to 180. Do we know 2 angles in the triangle now? So could I add them up and minus it from 180? Yes, you could. So we could do the measurement of angle N plus 90 plus 31.147 equals 180. That'd be 121.147. And when you subtract that, you get what? That's absolutely correct. I do not have time to do part D because the bell's going to ring in less than 2 minutes. But hopefully getting through those 3 parts really helped with solving the triangle. Videos for all my other classes are up, so if you had a question about one that we didn't get to, please check out the videos from either first, second, or fourth. Fifth period, we spent most of our time going over this particular question right here. I showed you guys where the answer key was. Do you all know how to find that in Canvas? Awesome. I do have office hours after school today. So if you want to, if you're able to, you can stay after and study with me for an hour after school from 2:30 to 3:30. Test is tomorrow. You'll be turning in your reviews tomorrow. Please make sure you bring them with you.